Bismillahirrahmanirrahim. Assalamu alaikum. In this lesson, we will discuss the chapter number 4, Periodicity of Elements, and part number 2, that is Mendleevs Classification. In this video, we will discuss Mendleevs Classification, Mendleev's Periodic Table, silent features of Mendleev's Periodic Table, advantages of Mendleev's Periodic Table, and defects in Mendleev's Periodic Table. Now let's get started. Mendleev's Classification. In 1869, a Russian chemist, Dmitry Mendleev, found that if elements are arranged in order of their increasing atomic masses, their properties vary in regular manner in a series. It states that physical and chemical properties of elements is the periodic function of their atomic masses. It is the Mendleev's periodic table. Mendleev had collected a huge amount of data about the elements from his own research and from scientists around the world. He was writing a textbook for his students and wanted to find a pattern to make sense of the data for them. So he made a card for each of the known elements by then 63. He played around with the cards on a table, arranging the elements in order of increasing atomic masses, and then into groups with similar behavior. The result was the periodic table. It was published in 1869. Mendleev's table was a big improvement on Newland's. To avoid inconsistencies, he took a big gamble, leaving gaps for elements that had not yet been found. He even named 3 of these, that is Eka aluminium, Eka boron, and Eka silicon, and predicted their properties. Some people thought this was crazy, but soon 3 new elements were discovered, matching his predictions. This helped to convince other chemists, and his table was finally accepted. Features of Mendleev's periodic table. It has 8 vertical columns called groups and 12 horizontal rows called periods. It has 8 vertical columns called groups and 12 horizontal rows called periods. Elements in each vertical column have similar properties. For example, the property of lithium is similar to sodium as well as potassium. Number 3. Vacant spaces were left for the elements not discovered until then. He proposed their names as Eka boron, Eka aluminium, and Eka silicon. The group number indicates the highest valence that can be attained by element of that group. For example, lithium is present in group 1, and the highest valence state of lithium is 1. Oxygen is present in group 6, and the highest valence state of oxygen is 6. Now, the advantages of Mendleev's table. It helped in systematic study of elements. For example, the study of sodium helps me at the time of